Today's masterclass is conducted by Sydney Informatics Hub. It's all about how we can get started using the IDE, the Integrated Development Environment RStudio, for backing up and version controlling using Git. And it's supposed to be a hands-on guide. We are not doing too much on hands-on, but of course, very important, interesting few steps, which will sort of, I think, excite you to use RStudio for doing backing up and version control with Git. So my name is Nandan Deshpande, and I work with Sydney Informatics Hub. So I'm sure most of you or many of you would be aware that SIH is a core research facility at the University of Sydney, and it enables excellence in computational data-driven research through advanced digital infrastructure, expert data consultancy, and analytics training. And if you want to know more about us, there's a link at the down. SIH can be sort of described in three very compartmentalized segments, but they all work together cohesively. On the left-hand side is the research computing unit, which is involved in high-performance computing, bioinformatics, modeling and visualization, and computing training. We have a big group, including a lot of data scientists and software engineers. They do a lot of consulting, collaboration works, analysis, and a lot of other things. And of course, cannot be missed is the statistical consulting, where a lot of you could have possibly interacted with. They do a lot of, actually, I can say a lot of, because they do much more than any of the other two groups, one-on-one consultancy at about the SDR level and above, for experimental and survey design, statistical modeling, and statistics training. And for getting into more details about what all we can do and how we can assist you in all your research and more, you can visit the website, which is, the link is given below here. And in addition to that, like I said, we do a lot of consultations. There are different ways in which you can interact with Sydney Informatics Hub. Short consults, we can help you with grand application supports, of course, data science, everything else what I talked about. And there is a specific program which we run once every month. I think it's the last week of, last Thursday of every month, which is a hacky hour, wherein it's all about, as the word says, hacky hour. You can bring all your computational requirements, small niggles, big problems, and just talk with any of the experts who are present in that session. And I think you won't go back disappointed. And then we do a lot of training, and out of which the master class is a part of. So quite a few things happening at Sydney Informatics Hub. Okay, what do you say, Mike? Should we start or should we wait?
Yeah, so we haven't found anyone.
Okay.
So I think we can just get into it.
Okay. The funny thing, and not so funny thing is, yeah, this is a hybrid session with no one in the room except us, which is good, which is not so good, because we can now focus on everyone in the Zoom. So, Georgia, do you want to speak something like that? I already introduced people to Sydney Informatics Hub and what they do.
Okay.
Okay. The question remains is, I got a lot of thumbs up, but I really haven't got a count about or a number of how many people have got issues with installations with reference to the link which I sent. Is there anyone who is completely stuck up, or who is okay with following this masterclass as more like a webinar, and then they can get back to us with their specific needs? If not, we can just proceed and try to do the hands-on. I'll just have a look at any of the comments which are coming in. Zinvi says maybe you should give us co-host. What does that mean? What did you want to do?
What's that?
Zinvi wants to be a co-host. Can we do it from there? Sorry guys, I just a technical question.
I'm not sure who wants to be a co-host.
Zinvi.
Oh, okay.
Yeah, I think she wants to do a few things. Sorry.
Yeah.
Okay, so since I haven't got a response, I think no answer is good answer. Everyone is up to date with the installations and ready to go. One thing which I haven't mentioned is there are two people on Zoom who will be actively assisting you if you get stuck up. I will be going slow when we do the hands-on. So anytime anyone wants to put their hands up or actually ask a question. Okay. So anyone wants to stop me, ask a question in the middle, just stop me if you have got a problem in any of the steps which you are going to follow. So let's get started. The learning objective, the main and one of the only focus of this masterclass, which is going to go on for next 1.5 hours or maybe less, 1 hour 15 minutes, is how to use the RStudio environment for doing backup and version control, especially using R Markdown projects that we use in GitHub. So what we will quickly do is try to introduce RStudio, R Markdown. I'm sure a lot of you already have experience with that, and that's why you're here. We can do a quick review about why and how to go about doing backing up and especially version control, and how can GitHub as a tool or a repository, a resource can be used for backing up and version control. And then comes the interesting part wherein we can do a small specific hands-on session wherein we will set up a GitHub repository. We can make a copy of that GitHub repository on your local machine, and we can make the changes. We can then try to push back the changes online and see if the changes get reflected. And that all we will do using RStudio. I'm assuming that some of you would have experience working with Git at a command line, which is all good. RStudio as a development environment with all its user friendliness makes this process really, really easy to use and more interesting and seamless, I can say. It has got most of the features, if not all. I'm not like the biggest expert in RStudio and Git, but I can say with confidence that many of the features which are to be used for efficient version controlling are available in RStudio. So R is a programming language. It's a software environment as such, and it has been used and being used by a lot of people in a lot of different domains, including data exploration, manipulation, statistical modeling, data visualization, and whatnot. I mean, I'm a bioinformatician. I'm working in genomics and proteomics for a long time, and I'm not really touched upon any of the fields which have progressed in the last few years, maybe almost like 5 to 10 years, where R doesn't have its say. A lot of different packages have been developed in R, and it's one of the to-go places for any programmer or developer or application-oriented tasks. RStudio, on the other hand, is a IDE. It's an integrated development environment, and as you can see on the right-hand side, you can see the different panes which are available in RStudio. It's used for R programming language. It provides a user-friendly interface for writing and executing R code. It also provides several tools to make the analysis really interesting, straightforward, and visualizations easier. So it makes working with R much more efficient. So that's also, and I'm assuming that many of you must have used RStudio. And where does R Markdown fit in? R Markdown combines text, code, and results. So as you can see on the right-hand side, there are sections where in the just text we want to render into the final document. There are segments which are in gray, in which you can actually put the R code or any other code in a different programming language. And when you render the document, it all sort of comes together. The text which is inside the code section actually gets compiled, and you get output of it inserted into the text area, which are both before and after the code. So finally, what you get is a very easily rendered document in variety of formats. May they be HTML, PDF, or Word documents. So applications of R Markdown are many. Again, data analysis, research, business intelligence, data journalism, and you name it. And a lot of different people in the university should have and could have used R Markdown for their own applications. So what are we doing here? We are trying to sort of say that, okay, all is good. Everyone was working in their different domains. They are doing a lot of stuff. There are a lot of things happening. Backing up is important. Backing up along with version controls are really important aspects of document management. Backing up is a straightforward process. You don't want to lose your data. You don't want to have only one copy of it on your local machine or anywhere else. And you want to make that a whole thing more streamlined than just making copies and duplicate copies and triplicate copies and naming them as version numbers, version 1, 2, 3. Version control records changes to the file, the changes which are made at different timelines, and it enables us to retrieve or go back to the changes which are made at different timelines. And that is very important and interesting because there is a possibility that what you did for 4 days back or 4 weeks back is more important or more correct than what you have done today. Or you could have lost the data today and you just want to retrieve it back. There is also that thing about working in collaboration with different people on a project with different groups, wherein a lot of different people make contributions to the project. So as a result of which there are multiple copies of the same data. And then you want to figure out, okay, how do you merge those requirements? Because you don't know what is more important, what is less important. You just want to have a proper look into it and then do the merging process without losing the important changes. There are different softwares available, options available for version controlling. Git is the one which we are going to use today, and you must have had some interaction with Git installations and what it is all about. It's a popular open source distributed version control system. That it is not the only one. There are its competitors like Subversion, Mercurial, CVS, and Git is supposed to be the most popular one, or one of the more popular ones, and the one which I have used and a lot of people in our institute use, and I think you are also used to working with it. In a nutshell, what GitHub, first of all, on the left-hand side can do, it can do backup, it can do version control, it allows you to work in collaboration with different members of your project if required, and helps you in reproducibility of the same version of a document, which if you require it at a later time. On the right-hand side, that's a general flow of how things work when you use Git or GitHub, say GitHub, which is an online server, which hosts your data sets for version controlling. What you have on the left-hand side is a working directory, which is your local working directory on your local computer. On the right-hand side is a remote repository, which you make on the GitHub server. When you make any changes in the local working directory, there are multiple steps you have to go through when you actually go from the local version of that particular document to backing it up on the remote server. First step would be something what we call staging, or it is called adding those documents for saving. And then the second step comes in is commitment. So the reason why there are multiple steps involved in the local side of things is not everything what you change, you need to actually save and then push it back to the online repository for backing up. So we can actually stop at multiple steps and figure out, okay, out of these 10 documents or 10 changes what you made, you just want to stage them for commitment, a few of them, and then commit them for pushing them back to the remote repository. Likewise, you can also pull your version of the remote repository in the GitHub when you want it and make those changes locally on your local machine. So this is the general gist of what you plan to do. Add, commit, push, pull. Basically, pull is first, because every time you want to work on your local repository, you need to be sure that you're working with the latest version of it and you're not going to miss out on any changes which you have done. So the first step is always going to be pull, then make the changes, then commit them, stage them, commit them, and push them back. And you can keep on moving in circles. A very simplistic approach. Things don't work as simple in real life. So there are going to be complications such as conflicts and all that. And we'll be just touching on a few of them as we go ahead. There are two more areas you can see under down, which are Git checkout, which is more to do with branching, wherein think about that you're going to work on an additional feature in a particular project. You always want to make a branch out of the main branch instead of just working on the original main branch. And you want to merge those changes as and when you verify what the changes are. And we'll look at some of these aspects as we go ahead. So we already looked at this. What are the pre-workshop setup requirements? You need an internet connection. Now that we know that everyone is on Zoom, they are responsible for their own connections. And I'm hoping because they are online, they have the connections working fine. You have set up your GitHub account. You have installed Git, and you have almost updated versions of R and RStudio. If all that in place, we are all set to go. Are there any questions? You can unmute yourself and ask the question if you want. Just looking ahead.
Why is there a two-step process, staging and committing?
Okay, I mean, my answer would be not everything what you change needs to be committed. There could be a reason why you don't really push back all the changes that you make. And Mike is here, maybe you can add on.
So yeah, it is. So the two-step process is confusing and sometimes annoying, even to experienced Git users. Essentially, the justification for it is that by staging, you're marking your files locally as the set of changes that you're going to push in the next commit. So it's a way of staging. The metaphor is like we're getting stuff ready to go into a commit. So And Junwei's just beat me with the explanation from ChatGPT. So she says you're selecting the changes to go in the next commit, and then you decide that this is the set that you're going to commit, and then you finalize it with a commit.
Maybe I would like to add to that. Maybe it's directly relevant. There's that thing about git ignore file as well, right? So you want to. There is a file which is created called git ignore, and whenever you don't want to really keep pushing on those changes which are either essential or confidential or not essential to be pushed back, or temporary files big in numbers, you don't want to really keep on pushing everything what is generated as a code result. You just want to be in control of what you push back.
Yeah.
So things like that. Okay. Are there any other questions? Okay. I'm sure. I mean, ChatGPT would have the best answer. It's all based on whatever data we have already generated over the period of years. Okay. So now that which GitHub we have, and I'm thinking there's some chat discussion going on. There are 2 GitHub versions available for staff and students. I don't know, at least the staff, which is the public version, and the enterprise version. And the enterprise version is specifically for doing a lot of project related stuff, more confidential stuff and things like that. Today, what we are going to do is we are going to work with the public GitHub version, which is at github.com.
I'll just add in that even on github.com, it's possible to flag repositories as being private.
Oh, yeah, of course.
And also, I'll just mention that although the Sydney University of Sydney Enterprise GitHub is good for code, which we don't want to be made publicly, we shouldn't keep high risk data there.
Especially the project related data.
Yeah. And as a general rule of thumb, you don't want to keep data on Git. You want to keep your code there.
Okay.
Yeah.
Cool. Okay, so we'll go the rest of the few slides after hands-on. So what we are going to do now is jump on this link for the masterclass, and I won't be. So I'll just open this link, and I won't be sharing this particular screen with everyone. But what I will be doing is what needs to be done actually. So if each of you want to follow this or me or both, you can do so at your own pace. And we are going to follow this particular menu wherein the presentation is done. And we are going to go over each of these submenus one by one. So first of all is the check prerequisites, which I will just have a look at. So if you have already done all the installations and registrations, you're all set to go. And yeah, there's this disclaimer about if you've got problems, don't worry about them. We can sort them later. Second thing, so the 3 steps we are going to do is we will create a test repository on the GitHub, which you have a registered account on. We will create a repo with the README file, and then we will make a copy of that repo offline on your local computer using RStudio. So everything what you're going to do is more about, I wouldn't say promoting RStudio, but showing the efficiency of RStudio in using Git and connecting to Git and doing all the version controlling. So we'll clone the repo using RStudio. Inside the RStudio itself, we'll first of all make changes in a README file or a Markdown file or both, and we can then try to push those changes back to the online GitHub and see if the changes are reflected. And if time permits, we can do a few more things. I don't know whether I'm looking at the right version of my link, but yeah, we will do that as well. So, okay. So, yeah. So if you're all at github.com or in your login and you're already logged in, you can press what we need to do is create a new repository. So what we can do now is click on this plus sign and say create a new repository. And you don't need the template, but the template is something like someone else has created a very standard kind of repo with a very specific tree structure, which is required for your project. And you can easily start off from, instead of starting from scratch, you can use the template. So there's a template option, but you don't need to use that now. Either use your personal ownership, or you can go to Sydney Informatics Hub and have fun. And you can give an appropriate name for this repository, say my repo, and this my repo for Masterclass. Okay. This is what we have. Okay, so this is available. You can put in a description line saying creating a repository. And you can keep this public because I don't think it's going to be much of a concern for anyone else but you for now. And you can also initialize a repository by clicking on this saying add a README file. And this was the file I was talking about. There could be a lot of files which get generated, or on one side they get generated and there are too many numbers, you don't need to back them up, or they could be too confidential for you to push back to the online repository. So you can always add all those files in this particular file called .gitignore, and then you don't have a license to use, so you can just create a repository. When you click on the green box, it will refresh and you will have your first or a repository on GitHub, which says my repo Masterclass RStudio or whatever the name you are given it. There would be a README file here. So there's nothing else in this repository, just a README file, because we haven't really put anything else there. What you now need to do is go back. You can open RStudio environment. You can click on RStudio as application if you have it on your system. And before that, you can go back to the repository. And if you remember, when during installations, you have created a personal access token, which is HTTPS token. So you have to pick up the link which says HTTPS, copy the link. So you're directing to this repository when you go to RStudio. And in RStudio, you can start off by going up to the top menu saying file. It's a bit small, but there's an option called file new project. And you will open a pop-up. It says new directory, existing directory, and we are doing version control. We are using Git to connect to RStudio or RStudio to connect to Git. So click on version control. There are two options, Git and Subversion. And you click on Git because that's what we are using. And you can click on the repository URL and paste the URL, which you have copied from the online repo. And if you just say tab, or if your project directory name automatically appears, it will pick up the name of the Git repository. And you will have to choose where you want to make a copy or a clone of this particular repository. I have selected mine, so you might want to, if your position doesn't look right, you might want to browse and select that particular location. Once you say that, a copy of this repository from GitHub will be created. It will create the project in that particular place. All goes well, and it has gone for me. It has gone well for me. We have created an exact copy of the GitHub repository on your local machine. And you can see that there are three files here. One is the gitignore, which we just talked about. There is a project file or r.r project, which is created when RStudio creates a project, and that needs to be always backed up. That's a standard practice, and that is the file of importance for you, which is a README file, which is blank, or maybe should have something. Let's click on it and see what is there. As you can see, it contains the name of the repo, and it contains the description which you put in the description field when you created the repository. There's nothing else. Now let's look at what's happening here. Now, because you have connected RStudio to Git, you can see that in addition to the normal tabs which you have here, environmental history connections, there is also a Git tab. And there are quite a few things happening there. Now, there are all these question marks. We'll see what that sort of question marks mean. Let's start with making the first change offline. So think about it. You have made a repo online, and now you're working offline because you have made a copy of it on your local machine. Let's say, let's add the first line in RStudio on my local machine, just to keep the local machine. And if we say save, you can see immediately that on the right hand side, you can see here that there is that name of the readme.markdown file appears with a flag which says modified. If you mouse over it, it would say modified. So the changes have been actually recorded, but they have not been staged for commitment. So I was saying there are a couple of steps which happen instead of just one step. So you made the changes, but are you sure that you want to stage those changes, add those changes for committing? Committing is a process wherein it sort of gets you ready to push back your changes to the online repository. So if you click on this, only this, then these changes are being staged or added for committing. I think if you can look in this particular tab here, diff tab, it should show you what happened one step before. So in what we see in the green box is some things which we have added in the README file. I will just say this now, and we'll just try to see what happens. Let's try to delete this file. I will copy this file. I will just delete it first and add a different file with some sort of difference and see what happens if you go to this file. What I wanted to show here is when things get deleted, they are projected in red. When things are added, they're projected in green. Things are very obvious in RStudio. They are no different than what you could do in command line. But half of the world doesn't want to work in command line. It's not very obvious thing to do. That's what RStudio gives you, a very explicit picture of what you are exactly doing and in a very beautiful color coding. So first thing what you can see is what are the changes. So the same changes could be sort of looked at if you look at the history tab. So every change what you make are also recorded into the history tab. Okay, so what you have done is you are just staged this particular file. Like I said, the standard practice is always stage the .project file, which contains a lot of metadata about the project for committing and pushing back. So that's a standard practice. And git ignore files, we don't have anything, but if we had something in that, we could have just clicked on it and said, okay, stage them, but all files which are recorded in the git ignore would not be pushed back. So then comes the next step, which you say commit these changes, and it opens up a pop-up, and there is a box which says commit message. The general trend is we don't want to say what you did, but what was the reason why you did this? So the reason why you did this was we were testing the first changes to be pushed to GitHub. And that's from RStudio. I would say RStudio specifically because we might end up doing something more at the end of our session. So this is the commit message. And it's a practice to, I think it's also mandatory to put in a commit message, and it makes sense to make a relevant commit message so that when you go back, sometimes you need to go back and check or make some changes or jump to different versions of your document. It's good to know what was your mindset? Why did you actually do these things and not what you did? Because that what you did is already recorded with the timestamp. Why you did was more important. So now you say commit. And if you can see there is no error, it says it has committed. Now, when you say committed, that doesn't mean that things have actually pushed. We are still on our local machine. So committed means they have been saved for pushing back. You close all these boxes, and there's a button called push here. That's where the actual pushing back of your changes happens to GitHub. And at this point, there is a possibility that some or many of you would require to put in either your personal access token or password. I think it should be the personal access token. Let me look at there are quite a few. Okay, Catherine is asking a question. How did you get to that window? Sorry, I missed you, Catherine. Can you tell me which window are we talking about? If you're still not gone to, oh, perfect. Okay, thank you. Sorry, I just don't keep check of what's happening on the Zoom chat. Okay, so once you've pushed it, you close the thing. Now, what you've done is you just added a statement, remove one statement. So you need to go back to your GitHub page and check out if all these changes have been reflected. So for that, you need to right click and reload that thing. And if your changes have been pushed back properly, you will get the exact copy of what you have, exact copy of the README file, what you have in the local machine. So this is one of the more important aims what we plan to do using RStudio for connecting to GitHub and doing backing up and version control. And we are going to discuss a few more things. How are you going with time, Joy? It's still 3:35. A lot of time.
You can, if you want to ask if everyone
Yes.
is okay.
So now that we have sort of accomplished the first task of making a repo, pulling it back to local machine, making a small change in the README file and pushing it back. We have seen what the tabs do. There's a diff tab which shows you the difference. There's a history tab which should show you the history that the various steps which have been we have been doing in terms of backing up. There's a pull tab, push tab which you have used. There could be a few more things we can discuss after this, but are we all here? Were we all able to do this? If there's anyone who has got any questions, please to ask us. Or we can, once we are done, once everyone is at this point, we can move ahead and all good. If you want to, if everyone can put like a thumbs up or something so that I can know that you're all good. I got 5 thumbs up, 6. Cool. Looks like we are all set. The next thing which I wanted to discuss was, and this is something which, just give me a minute. Okay. This is something which I relate to so much. There were a few years back when I was working at a different place and I was working by myself in a research group, doing really well, but I had no reason to use GitHub. I didn't use it for a long time. When I started doing it, it was more because of peer pressure. Some of my colleagues who are hyperactive, they started using GitHub. They told me, oh, use GitHub, because then I had to do it because my boss said so. But I didn't do it right. And what happened was, after doing a few changes and pulling and pushing, I had no idea what I had done. And I lost my data rather than backing up my data. And that's not the way GitHub should be used. So then I started doing it more methodically, especially after coming to Sydney Informatics Hub. And also I had to collaborate with other group members. And that was the other reason. We have got a good group and they talk to each other all the time. That's where the real significance of GitHub comes in. The one thing I want to stress is, irrespective of whether you're working by yourself on a project or you're working with a couple of or more group members, the first thing you would want to do is, when you make any changes to your repository, may it be offline, online, is you need to use something called Git branches. And I'm sure people who have worked with Git branches on the command line, and there is a very easy way of working with Git branches on RStudio, wherein there you can see all the branches which we have. At the moment, we do not have any branch. We have got only the main branch. But if you want to make a new branch, you can easily make it. You don't need to go at a command line. You can just click on the new branch thing. You can name it and you can start working. Now, the idea of branching is, when you pull yourself away from the main task. If, for example, I will just show you. Say, for example, this is your flow of your repository. You are starting at point A. Up to point B, everyone is doing the same thing. But at point B, maybe you want to add a new feature to your repository. Maybe it's a coding feature, maybe it's just a document which you want to add. The best practice is, you want to make a branch inside GitHub and then bifurcate and then make all those changes. After making those changes, there would be a way to actually merge those changes back to the main branch, provided everyone is in the group, or you yourself are confident that the changes are not going to conflict with any other changes people have done on the main branch. So that's the part we are talking about using Git branches. The basic rule of thumb, even after doing Git branches, is to avoid merge conflicts. When you try to merge those changes, there is a possibility that there are going to be conflicts. The best thing would be communicate often. If there are other people involved, tell them what you have done. Try to figure out at what time point people have done things. Tell each other what they're working on. The best and the only way of not messing up your GitHub is even using RStudio is pulling before you make any changes and then committing and pushing. And always keep committing in small chunks so that you're always looking at the latest version and working with the latest version. So this is a way where we can do things. We can pull the version from GitHub, make changes, add to those changes, again pull so that nothing else has happened on the repository before you push it back. Then you commit and then you push. If you follow this, things become a bit simplistic and straightforward, and they work for you most of the times. I can say most of the time because I've still have problems, but there's no getting away from GitHub. Okay, so based on this, again, any questions? I can actually, because we are sort of nearing to the last challenge, which I feel would be interesting. I just did it at the last minute, because I thought, yes, if people have got their installation set up properly, which was the case today, which is a very good thing, we will have some time for doing something more interesting. So let me know. I'll wait for a minute. Georgia, do you think I should wait? Or you can carry on? Yeah, okay. There are some comments coming in. Okay. Okay, so I think everyone has managed to do what we plan to do at the very onset. And the last challenge, I think, could be interesting. Sorry, my spelling for simulate is wrong. I don't know why that has happened, but I tried to make that change last minute. Sorry, I mean to say simulate. And maybe inside, it's all good. So forgive my English. What are conflicts in GitHub, and how does RStudio assist in removing those conflicts? So we can have conflicts in GitHub in multiple different ways. One of the two main ways which I figured out they can happen is when there are multiple people, users who are working on the same files or files simultaneously. So think about it that there's a README file and you're working on the same file, you're adding something, subtracting something, and you're pushing it back to the online repository, and someone else is doing the same thing. GitHub is no one to make a call saying who needs to be prioritized, which changes need to go first or the other changes need to be discarded. It's up to you to, if there is a conflict, to figure out what to do with those conflicts and then merge those documents properly. A conflict can happen only when a single user can merge branches or commits in a different way. And we'll try to do that. We'll try to simulate this kind of conflict. So when Git detects a conflict, it stops the merge process, marks the files which are affected by it, and then makes you look at it. And that's where RStudio also is very intuitive. It sort of shows you all those things in green and blue, green and red, and then tells you, okay, these are the things which you need to look at if you want to resolve your conflicts, and only then you can go ahead for pushing the changes. What we plan to do in a very simple way is, okay, and I will tell you, I'll not show you first, maybe we can have a trial of how people can do things. What I plan to do is, what could happen, say for example, you pulled your repository from your online version of it, and you're working on it, and you have pushed some changes, and then you have pulled your repository back after 5 days. Now, it is also tempting sometimes to just work on the online version. So suddenly you look at your online version, you click on the README file, and there is an edit button. So you click on this edit. You can easily make changes here. You can just add something. So for example, what I can say is I'm adding a line in the online repository without even thinking about what could happen offline in my RStudio backup or RStudio version. So what has now happened is, if you go ahead and now say commit, you have two different versions of your same project. And if for whatever reason you decide not to pull before you start making all those changes, there is going to be a version difference. So here you don't pull any changes, and you say I'm adding one more line in RStudio and save the changes, mark the changes for staging, and look at the difference. You can see the difference what you've done here, but when you commit them, they will get committed. If you can commit them, commit changes before pulling. Simplistically, that's what you've done. You're not given any regard to the actual flow of things that could happen using Git. You're not pulled changes from your online repository before making any additional changes. So if you now commit is fine. But when you try to push those changes back to your repository, I'm assuming that there would be, if you look at it, it says failed to push some references because there are updates rejected because the remote contains work that was not actually pulled back. So what it says is you need to pull the changes first and then make the push. So that's one of the conflicts. And we actually created a conflict by knowing that we are going to do that, but normally it happens by accident. So what I will do is I will go back one step. I will try to pull it. It says you have diverged branches. So what it's trying to tell us is in your RStudio, on your local machine, you have got one branch created because there's some different data at different time, and on the online repository, you've got a different branch. So you can't do that. You can actually, so for that, it sort of gives you a hint saying what needs to be done. There's something called git config full release false. That's a command it says you need to run to merge those changes. So if I go back, copy that command and go into the terminal here. There's a terminal available inside RStudio, and just paste that command here and then try to pull back the changes. What you don't want to do is lose your changes. What you don't want to do is lose the changes which have been made online. So now if you say pull, it will pull something. So it says auto merging the README files. There is a conflict. Automatic merge has failed. But what it has done is, if you look at this particular file here, I'll try to make this big. Put in some headers. There are these arrows which have been put in. So what it has done is it has put in the changes which were made independently in the GitHub repository and made by you. So what you've done is let's add the first line in RStudio on the local machine. This is added on the online repository, and this were added in the RStudio on your local machine. So both have been put. Now it's up to you to figure out how to resolve the conflict. You need to figure out, do you need to keep both? Do you need to remove one? What needs to be retained? What needs to be discarded? And all those things. So basically, it's just putting everything up front and then makes you make the decision. So here, what I want to do is just remove this debugging characters, this header line. I feel that, okay, one of these lines needs to be retained, but the next line can be changed. And then I make a call. I stage these files, and then I see the difference. So there are all these changes made, and then commit them. So I want to make my what you're done is the GitHub puts the prerogative on you to figure out what you need to do. So now I'm doing is I'm committing after manually resolving the conflicts. And it says commit, and then I say push. Push properly, because the only conflict before was it did not know what to do. It did not know whether to retain the changes which were done online or to retain the changes to be done offline, or retain both or discard both. It gave us a chance to make the change, make that call, and we did that. And so now when you go back to your online repository, which was only this thing, it I think should have what was done offline plus what is done online. So this is one of the kind of conflicts that can come in. And think about what could possibly happen when there are multiple people working at their own time, making their own changes. And there is a possibility that you could be looking at the same document and pushing those changes. And that's where conflicts needs to be resolved. That's why you need to go back to these guidelines and follow rules of thumb. So yes, there's a lot to it. there are quite a few things that can be done with RStudio in addition to what we have looked so far. But my experience with RStudio is my experience with using Git and GitHub has become much easier and much more streamlined. I think that's all we plan to do, but I was looking at, can I please ask, do we need VPN to access Git through RStudio? What I can say is anything already got answers. Yeah, we don't require. Yeah, there was this question and Mike has answered it. Just to clarify, thanks, Alex.
There's a question. Why is there a pull stack in the middle of the workflow?
Oh, okay. My understanding, and anyone can add, Georgia or Mike. Think about it that you have pulled something from your online repository and you are so engrossed in making those changes and the changes take a long time. Then you stage them and you commit them. There is a possibility that the online repository would have been changed by someone else. I'm assuming. Mike, do you have any comment on that?
Yes. So the idea is that if you're all working on one branch, which is what we're sort of describing here, you pull to get a version of the code that you want to work on. That can take any amount of time. But if you're collaborating with your team, other people may have changed the code, changed their copies of the code, and pushed commits to the repo. So before you commit your changes, you want to pull so you get the most recent version of the code. Now that pull you may end up with conflicts as the result of that, because you may have been working on something that someone else was working on. But it means that you can resolve those conflicts and be fairly confident that what you're doing is merging your changes with the most recent version of the shared code repository.
Right. So in that case, Mike, I have a question. Is it possible for you to ad hoc push changes without pulling them and just, what I want to ask is there a way that there would be no conflicts which are popped up, but then you can just throw changes on something and just try to nullify someone's work? Is that possible, or it will always ask you to, I mean, creating a conflict sounds like an advantage, right? Then you can at least look at it.
So I was going to mention this in the chat. It's always possible to create, to push code that Git won't have a problem with, and we'll just add a new commit on top of it on the repo, and for Git not to actually complain about any conflicts. Git will do its best to take your version of the source code and the version that it finds on the server and merge them. And so go through every file and figure out what lines they have in common, and they're no problem, and then merge all the changes. And if the changes don't actually overlap, it'll go, great, this is fine. I don't have a problem with this. The difficulty there is that you might still have introduced a bug by changing something in one part of the code that's inconsistent with changes someone else has made in another part of the code, which means that when you're working collaboratively with code, you need other things to ensure that your code's working. Like when you do a Git merge, test it, make sure that it still runs, that it still does what you think it does, because Git really only cares about the line by line differences between things. And it can't, when it's doing a merge, guarantee that your code still works, even if it doesn't find any conflicts.
Okay.
I've made some changes into your README files if you want to try and do something with RStudio and see if you can pull or push or
Okay, so I'll pull it first.
make commits. No, don't pull first. Just try and maybe do
I'll
something.
Push. I'll do something.
Push and see if you have
I'll
conflicts.
just also add my thing. Added by Nandan. So I will stage the changes now. So what Georgia said that she made some changes in my repo because she can. And so that's a good practice. That's almost like we are working as a collaborator. And I would commit it. Just to saying, checking conflict possibly with Georgia's changes and say commit. Commit is of course done, that's fine. And then we'll try to push it. Yes. Failed to push some changes, and that's the same error which has popped up because I've not added to the rule saying pull it before I push it. So I have got a different version than what Georgia has created in my repo.
And it tells you what to do. I mean, if you read the hint, you'll get hints.
Yeah, we'll get hints.
RStudio.
So these are the hints which are very important, which we used last time. Updates were rejected, why they were rejected. So they're usually caused by another repository pushing to the same reference. You may want to first integrate the remote changes. What you want to do is pull first before pushing again. So now in this case, I think the auto merging has worked because I think the changes need not be in the same lines. Georgia made some changes, but they were in a different parts of the file or a different file. I don't know what she has done, but we'll see that. We'll just pull and we can now see what the changes were. So you feel your changes would be reflected here? This one? See, so that's a different scenario than what we did a few minutes back. What I've done, I would just messed up the same lines in here as well as online, but Georgia has made the changes in some other part of the file and they didn't conflict with what I had done. So when I pulled the changes first, they got merged properly into the file. And now I can make my changes and can push them back. So, yeah. Let's see what is going on Zoom. Yes, Zinvia said a very good point. Git will flag conflicts during a merge operation when it's unable to automatically merge changes. That's perfectly right. Line by line, yeah.
Catherine is asking, is this working similar for a R file or R markdown file?
It should be any of the files, right? What do you think? Yeah. It should be any file irrespective of the file type. It's more about the line by line thing. That's my understanding. Yes. So even if you're developing a code and just have different modules written somewhere. Yeah, and we are not even getting into branching now. So Mike has got a comment which talks about Git not being particularly good with binaries. Oh, okay. So Mike, just to all it can say then is binary files default. Oh, okay. Okay, so it's not really good with binaries. They say only that.
Yeah, just it can handle when I'm talking about binaries, it's perfectly possible. I mean, I mentioned before that Git isn't ideal for really large data sets, but it's perfectly possible for people to put images like figures for something that's been generated by your code. Git will happily accept them, but it can't do any kind of sophisticated checks to see whether there's conflicts in them. All it can say is, oh, this version is different from that one.
Okay, thank you. Anyone has got any specific questions related to working with RStudio and Git? Okay, right talk slides. So just curious, how many people actually have worked with Git before, or normally work with Git before for their backing up? You can put your hands up. I should have asked this question at the beginning of the session, not at the end, but still curious. I'm getting a few hands up, like few. Yeah, it's a good time to start. Okay. There is a comment in Catherine says, I guess you can delete the local file when you don't need it, and the GitHub repo is still there. You can reconnect to it.
It's a bit, so if you do that, if you delete a local file, I wouldn't recommend it because Git is then going to see that deletion as a change you've made. And it might decide to push that change, in which case it'll delete the file on the repo. The sort of idea is that your local repository in RStudio is your copy of everything that's on the repo. So you don't really want to delete the stuff that you've got locally. Does that make sense? And I think if we did experiment with that and deleted one of the files locally, RStudio's Git pane would show us in the status that there was something that had gone missing.
Okay. I mean, if anyone wants to, now that we actually made the changes and pull and push them for a text file, you can try out making a R markdown file, a new file, and work with that. And just see if it works fine. Adding a file is also one good idea. First markdown, so I'm making a markdown file. In that file, it appears here, and I can stage it for committing. And there's a new file, so there's not like changes in the file, but a new file itself. See what difference I can see. New file, the markdown file itself, everything is a change, right? Green addition. I comment. Added markdown. Shall go seamlessly, and you see markdown file. Yeah, that's your first markdown file here. Just playing around. The question in Zoom. Yes, the question mark says that I think they are not being added for commit yet. Oh, there was a thing about it being untracked. Very true. So we thanks for all that. Yeah. So every flag has got a meaning. Oh, sorry. Sorry, please don't read my Teams chat. Okay. So U means untracked. All those flags have a very specific meaning. A is added and M is modified.
If everyone is.
Are we all good?
Everything
We can keep asking questions and doing things if you want, but this is what we plan to do in the masterclass. This was all the hands-on. Good. It was a good thing that everyone got their installations in place. I was personally very concerned about someone. There could be all different things happening, right? So, but Georgia, I can say, was very optimistic, and that worked. Okay. So.
Have you told them about Aki Hour?
Or?
Aki Hour?
Oh yes. One thing, if anyone I'll talk to them about it. Maybe we can go back to the slide and just reiterate. And so, like I said, this is all what we do. This is all what we do in the sense that a lot of things what we do. And one of the more interesting things would be if someone wants to ask any kinds of computational related questions. If I'm not wrong, computation is a very basic core kind of thing. Related to statistics, bioinformatics, high HPC, data science, whatever. Small questions, bigger questions, they can come to Hacky Hour, and Hacky Hour happens on the last Wednesday. What is it? When is Thursday?
Third Wednesday.
Third Wednesday of every month. There's a particular time, and I think there are details on the provider on the Sydney Informatics Hub website. And it has so happened that people come for Hacky Hour, and they go back as if it was a happy hour, so they get all the solutions. And sorry, a bad joke. But,
do you have any link if they want to keep
there would be a
looking at
link.
Git or RStudio?
For the Hacky Hour, or?
No, for this masterclass. If they want to have some basics about Git.
Oh yes. We missed that last page, right? So, good. Georgia is here. So let me know if you can all access these slides which I have put up as PDF. If not, I can share with you, and Georgia will send it to you. Now, this is important. Thanks for attending, but it's always good to have a feedback. We could have done good things in some places. We could have lacked on few places, and we always want to improve. So if you can either scan this or QR code, or you can click on the link, and it just takes like a few minutes for you to put in some very basic details and give us feedback. And I'm sure a lot of people would be very interested in getting into more details about Git. There are quite a few online resources available, which we have also gone through, and for this particular masterclass and for other things. So one of them is this one, but there is an in-house introduction to Git workshop, which was conducted, I think, by Mike before. So you can click on the link and have a go at it. It's a very beautiful workshop. All details possible for getting started with Git. And yes, the other links are also here. So yeah. And there's always ChatGPT if you miss on any details. And thank you very much to all my colleagues, including Georgia, Meredith, Michael, Lynch, Sinvi, and actually everyone at the Sydney Informatics Hub, because I got a lot of feedback about adding on some important, interesting things which I could have missed. And thank you everyone for attending. And yes, I would like to add, there is one person in the room. So that sort of qualifies us to call this a hybrid class and not just an online Zoom. So all thanks to her that she's here. And of course, all thanks to everyone else to make it hybrid, because we need all to do to different places. There are a lot of cool, thank you. Thank you, everyone. But still, I'm not going to be around for a while. So if there are questions for next few minutes, you can just keep, or you can always email us. There is that query about having a similar workshop on Visual Studio Code. Yes, it's a very interesting software, and we work with it. Yes, we will be sharing the recordings.
Send the link for the feedback on the chat.
Yes. I'll do that now. So please, if you have not already left, please don't leave.
Yes. And the name project. Yes. I guess the thing I do.
So here's a link if you are unable to look at my slides. or access the slides for whatever
So
reason.
it's just the average touch. Yeah. On the managing, but if you collaborate with someone, it's possible. It's in French.
And if there are no further questions, I think we can.
French is in RStudio as well, so you can see here.
Mhm.
The moment, and we can.
It's just gonna make me.
Yes, she's from here. New branch.
Mhm. Mhm.
I can try. What did you create your repo?
Where did I create it?
Yeah, is it in the SIH GitHub?
No, it is just on my own personal one. I just did
And you are.
I'm Emily L. McLean. Oh, maybe I can make it discoverable. This.
And we are done. Are we? I think we're the only ones, or maybe.
Sure, if there's still someone in some breakout rooms.
Are there?
I don't know.
Are there breakout rooms? Did we? Oh, there is.
Yeah, I started some breakout rooms
Okay.
because someone needed some help.
Okay.
Getting past. I think authentication hadn't worked once, and then
Oh.
creating the repo the second time was failing because it was trying to create it in the same directory.
Ah, yes, of course.
We
Yeah.
sorted it out.
Thanks, Mike.
So if there are no more breakout rooms and everyone's happy, just, it's okay.
So last chance, if you have any questions, do let me know. Or this is the end of the masterclass. So we'll meet you next time. And I think there's a next masterclass scheduled in next month. And we'll keep having one every month for a while. So have a look. Thank you. I will just keep this on because there are people in the breakout rooms.
Puts it under this one. It's